world of coding, Lua is still a fairly small player, yet its unique features have made it a favorite in video game development and a welcome addition to the toolkit for many other programmers. What were the design goals of Lua, and how did their implementation propel it from a tiny in-house project to an internationally employed scripting language? Join us as we head to Rio de Janeiro to speak with Roberto Ierusalimski, Associate Professor of Computer Science at the Pontifical Catholic University.
We started Lua many years ago as an in-house tool for two specific projects that needed what we call at the time an extension language. And then other users started to find that tool useful for other programs, and its use spread a lot. And so now Lua is widely used in embedded devices. It's embedded in cars, in TVs, in keyboards, in routers, all kinds of equipment. And of course, a very strong niche in games. It's widely used in all kinds of games, as for example, World of Warcraft and Angry Birds, which is mostly written in Lua.
What sets Lua apart from other tools is its particular set of goals: simplicity, small size, portability, and embeddability. Designed to interoperate with other languages, the entire implementation of Lua has just 25,000 lines of C code.
Size and portability are very important points in the design of Lua. We are kind of obsessive with those points. As an example, Lua still runs in 16-bit machines, compiles without problems in those machines. It also helps Lua not bloat the applications that use Lua. That's very important for games, for instance. And size also helps performance, because it allows the interpreter to fit mostly, or at least a good part of it, to fit in the cache of the machine.
Another strong selling point for Lua is its simplicity. Fast execution, a simple interface with the host language, and a short learning curve allow even non-programmers to create customized functions with relative ease.
The simplicity of Lua comes mainly from our philosophy of mechanisms instead of policies. Lua offers few but very powerful mechanisms, such as associative arrays, closures, and coroutines that we can freely combine, and then with this combination we can create more powerful concepts such as modules and objects in the sense of object-oriented programming.
To be sure, small size and flexibility can have their drawbacks, and Lua is not a fix-all for every application. But its success so far has shown that it fills a niche in the programming world.
I think Lua has a very bright future. At the same time that machines get bigger and more powerful, new, smaller machines pop up at the other end of the spectrum. We can think about smart watches, or the embedded devices, or the Internet of Things. And I think Lua is probably the best fit for those new platforms.
Learn more in the contributed article, A Look at the Design of Lua, in the November 2018 issue of Communications of the ACM.